Hello, viewers. I am Akpeji Honesty, your chemistry tutor. I will be sharing this chemistry topic with you. So I would like you to just subscribe to this channel, like the channel, and share to other students. This topic is catalysis. The topic is quite lengthy, the content is quite lengthy, but I'm going to be breaking it for your understanding. What is catalysis? It is simply the acceleration of a chemical reaction by the action of a catalyst. Or simply put, it is a process of increasing the rate of chemical reaction by the introduction of a catalyst. That means you have a reaction that wants to occur, and because the reaction is slow or sluggish, if you introduce a catalyst, then the reaction is accelerated. So the process by which the chemical reaction is being increased, is being accelerated by the introduction of a catalyst is what is referred to as catalysis. And from the definition, a word is mentioned called catalyst. So I'll be doing a brief introduction to catalyst and some things that has confused students about the issue of catalyst. First of all, what is a catalyst? It is simply a substance that increases the rate of chemical reaction without itself undergoing any chemical change. That is what a catalyst is. Any species, any substance that is added to a chemical reaction without itself undergoing any chemical change is called a catalyst. And with this definition, a catalyst has different characteristics or different attributes, properties that made it a catalyst. Number one, it is that catalyst activate the rate of reaction. But catalyst cannot initiate a reaction. This is this has brought confusion to some students that catalyst initiate a reaction. No, a catalyst does not initiate a reaction, but it promotes, it activates the rate of reaction. The reaction must have taken place, but it is very slow. So you initiate a catalyst, you add a catalyst, small catalyst, as small as it is, it will help to activate the rate of that reaction. So number two characteristic of a catalyst is that catalyst may undergo physical changes but cannot uh, undergo chemical change. I think that is self-explanatory. Number three, catalyst does not change the equilibrium constant of a reaction. What the catalyst does is to increase the rate of the reaction. The equilibrium constant in an equilibrium reaction remains unchanged. It does not disturb the equilibrium constant of the reaction. And then number four, catalysts are specific in nature. I am going to create a video that talk about specificity of a catalyst, bringing different equations that explain the specificity of a catalyst. So I will not be explaining that here. So catalysts generally are specific in nature. That means we talk about specificity of the catalyst. Then number five, catalysts are selective in the type of reaction they undergo. They are actually selective. So I will be creating a video, and in that video, you will quite understand the difference between specificity and selectivity of a catalyst. Then in that video, I'm going to include other terminologies that are used as associated to catalysts and using equations to develop those definitions. So number six, catalysts are reborn. Catalysts are reborn. What do we mean by that? It means that you can recover them at the end of the reaction. Okay, yeah, as you use them at the end of the reaction, they are not used up. They are also, you can get it back. So because catalyst can be gotten by, can be recovered at the end of the reaction, you simply say catalysts are what? Reborn. So we have types of catalysts. We have simply positive catalyst and negative catalyst. So, what is a positive catalyst? A positive catalyst is a catalyst that enhances the rate of reaction. It is a catalyst that activates, that increases the rate of reaction. If a reaction is very slow, if you include a catalyst, then, and the catalyst increases the reaction, it increases the rate of the reaction by reducing the time taken for the reaction to take place, then it is referred to as a positive catalyst. And I'm going to give an example of a positive catalyst. For example, I talk about positive catalyst. An example of a positive catalyst is example is manganese dioxide, MnO2, manganese 4 oxide, or simply manganese dioxide. This is actually used in the decomposition of potassium trichlorate, KClO3. When it is being decomposed, when it undergo decomposition, it will bring out 2KCl plus O2. This reaction is not balanced, so you can balance it by putting 3 here. So with this, the reaction is balanced. I think 6 oxygen, 6 oxygen, 2 potassium, 2 chlorine, 2 potassium, 2 chlorine. So the reaction is balanced. This reaction, when you decompose potassium triiosochlorate 5, as you decompose this reaction, if you introduce a catalyst called manganese dioxide, it will enhance the rate of the reaction. If the reaction is supposed to take place in 3 minutes, that means in the next 30 seconds, the reaction has come to an end. This is to tell you what positive catalyst is all about. So this is an example of a positive catalyst and the type of reaction it can catalyze. Another example of a positive catalyst is seen in the contact process. Contact process describes the industrial preparation of sulfuric acid. In this equation, when sulfur dioxide is being oxidized, you are going to have this. You are going to have this. So this, if you are to balance this equation, if you put 2 here and you put 2 here, this equation is balanced. So with this is a reaction that describes the industrial preparation of sulfuric acid. If you introduce a catalyst, the catalyst that can catalyze this reaction is either you use vanadium pentoxide or finely divided platinum. One of these can catalyze this reaction. One of these is the catalyst used in catalyzing this reaction. So this is an example of a positive catalyst. What does it do? It promotes, it fastens, it quickens the rate of the reaction. That is what it does. Another example of a positive catalyst, it is in the when you react nitrogen gas with hydrogen gas in the industrial preparation of ammonia called Haber process. If you are to balance this reaction, you are going to have 2 here. That will give you 6 oxygen. You will have 3 here. That will give you 6 hydrogen and 6 hydrogen. Then 2 nitrogen, 2 nitrogen. So this equation is balanced. So the catalyst you need here is called finely divided ion. Finely divided ion is a solid catalyst. This are in gaseous form. So this is a solid catalyst. Even this is a solid catalyst. All these are solid catalyst. This is also a solid catalyst. Okay, this is in gaseous, gaseous. So with this, you have 3 positive catalysts here given to you. This ion is the catalyst catalyzing this reaction. And that means when you react these reactants together in the presence of ion, you have the product form. And this describes the industrial preparation of ammonia, what we refer to as ABA process. This is called contact process. Okay? So we have what we call the negative catalyst. This is the number one positive catalyst. Then you have negative catalyst. That is number two. What is a negative catalyst? A negative catalyst is the substance or catalyst that reduce or retards the rate of reaction. What it does is that it reduces the rate of reaction, it retards, it inhibits the rate of reaction. Negative catalyst does not poison the reaction. It simply inhibits the reaction. So because of that, we call negative catalyst inhibitors. Okay, they are simply called inhibitors. By the name as it has been described, it means they can inhibit reaction. So examples of negative catalyst is seen in the decomposition of hydrogen peroxide. The composition of hydrogen peroxide. You have hydrogen peroxide H2O2 to give you when it decompose you are going to have H2O plus O2 and water plus oxygen gas. And this reaction can be cat this reaction can be retarded. It can be retarded, it can be inhibited by a negative catalyst. It is not balanced. You put two here to balance the reaction, because any reaction you have not balanced will not give you the right application. Okay, so what the catalyst, the species that can retard, that can reduce this reaction is phosphoric acid. In short, not only phosphoric acid, any dilute acids, dilute inorganic acid or dilute organic acid can retard this reaction. So example, the negative catalyst, e.g., I can retard it is dilute dilute acids like H3PO4, which is phosphoric acid, or you have acetic acid. This is an organic acid or acetic acid. It reduces that. Then you have another one, or glycerol also. Glycerol can also retard this reaction. Glycerol can retard this reaction. So these are negative catalysts that can retard this reaction. It can inhibit this reaction. Another example of negative catalyst is seen in the oxidation of trichloromethane, which is CHCl3. When it oxidizes, it gives you carbonyl chloride and water plus chlorine gas. This reaction is not balanced. To balance it, you put 2 here, give you 4 hydrogen. Put 4 here, give you 4 hydrogen. If you balance it there, you have 3. Then you have 4 to balance this. Okay, this reaction with this is balanced now. Okay, so this reaction can actually be retarded. As it is like this, the reaction takes place on its own and it's very fast. So, but if you want to retard this reaction, you want to inhibit it or you want to stop it, okay, what you introduce is a negative catalyst. If you introduce a positive catalyst here, it will fasten it. So when you introduce a negative catalyst, the negative catalyst you can add there are actually alcohol. If you add an alcohol here, negative catalyst, is alcohol. We retard this reaction. And the type of alcohol majorly used to be ethanol. I hope you can see what is being written here. Ethanol, which is C2H5OH. So this and ethanol is either you use 2% ethanol. Okay, 2% ethanol. You prepare 2% ethanol from the stock bottle. If you add any volume of the 2% ethanol into this reaction, what you will see is that the reaction that was fast before will become very slow. That means it becomes an inhibitor. I believe you quite understand what I have shared with you, my viewers all over the world. So kindly like the video, subscribe to it, and share to others. You check the other videos I'll be uploading, and you will have a good understanding of this topic. Thank you. I remain Mr. Akpeji Honesty, your chemistry tutor.